All right, so let's go ahead and go over the graphing portion of graphing and word problem portion for your quiz on Thursday. Couple of things I want to talk about with the graphs. We did talk about graphs yesterday, and when we sketch the graph, remember we cannot put that equation into our calculator because we can't put in a base of 3. Remember, everything has to be in base 10, which means I need to use change of base first to write this in the form of y equals to the change of base. So I'm going to rewrite this as log of x minus 2 over log of 3. Okay? So that's actually what I'm going to put in my calculator. Go to y equals, go ahead and clear whatever you have in there, and you want to do log of x minus 2, end your parenthesis, divided by log of 3. Please make sure you end that parenthesis or else you're not going to get the correct graph. If you press graph, you can kind of get a feeling for what this graph looks like. Okay? Again, this extends down. It just doesn't show it because you have that asymptote value. And so it's not going to show that extending all the way down. However, you know that you can evaluate it. So you're going to have an asymptote right here at this line. And again, if you look at your table of values, you can see where the error starts. The error messages start at 2. So again, you want to use this table of values to graph it. So if you use that table of values, I've already actually put that in right here, so I'm going to pull that over just so that we can look at that table of values. And again, you can see that at that 2 we get that error message. So what I like to do is kind of draw in the asymptote so I know not to go past that line when I'm graphing it. Okay, so here's my asymptote. It's along the line x equals 2. Remember the x equals because it's a vertical line. Okay, and then I can sketch my graph. And I want to use numbers or values from my table. I should see a table. When you're graphing on a test or a quiz, you need to make sure you show me your table. They're 3, 0, and then 5, 1. 1, 2, 3, 4, 5, 1 are going to be 2 points. Now again, remember, when you graph this, it's going to just all of a sudden drop, and it's going to get closer and closer to that line, and then going in this direction as well. Okay? So that's how you should be doing your graph. Domain. Look in this case. We're going to look from side to side. And if you notice, as I look, I don't reach the graph until I get to my asymptote. And that's where I'm going to start my domain, is at the value of 2. Now again, I don't include 2 because it never reaches that line. Remember, I got an error at 2? So it never quite reaches 2, which means I have that curved parenthesis. And it goes all the way to infinity because it's going to keep going to the right. Now range, you want to look up and down your graph. You notice this is going to keep going down, and this line is going to keep going up as it goes to the right. So my range is actually going to be all real numbers, from negative infinity to infinity. X-intercept, I already noticed that when y is 0, x is 3, so that's where it hits the x-intercept. Is this ever going to hit the y-intercept? No, it is not. Because, remember, my asymptote, it's never going to cross over that asymptote. So I have none in this case. And then, of course, we already talked about the asymptote as an equation, x equals 2. All right, so that's what I should see on your test. I should see it rewritten first, using change of base. Then I should see the asymptote on your graph. I should also see the approximate look of the graph. Domain, range, x, y-intercept, and asymptote. Okay? So the next one, let's go ahead and move this out of the way and erase this mark right here. We don't need to look at that for the next one. Let's go ahead and see what it's going to look like. We want to first rewrite this using our change of base. Now, this one's going to be a little different. Notice the x minus 3 is not in parentheses. Notice how x minus 2 was in parentheses here. So therefore I know that this minus 3 is not part of the log. I am only taking the log of x, which means this minus 3 is going to be at the very end of the equation. So I'm going to use change of base just for log base 2 of x. So I'm going to rewrite this as log of x over log of 2, and then I'm going to put the minus 3 at the end. So when I'm putting this in my calculator, this is important because it does depend on where you put that minus 3 in the equation as to how it looks. So you're going to do log of x, end the parenthesis, divided by log of 2, end the parenthesis, and then I'm going to tack on the minus 3 at the very end. Okay? Press graph and see what the graph looks like, but we are more interested in the table of values. So hit second graph, and again we want to find where our error starts, and our error starts at x equals 0. That means that that's where our asymptote is going to be. And notice that does correspond with whatever is here with the x. Notice up here the x minus 2, my asymptote was x equals 2. Log of x, there's nothing there, so my asymptote is x equals 0. So again, let's go ahead and draw that in. Asymptote, here's x equals 0, right along the y-axis, there's x equals 0. Okay. And now let's go ahead and get our values from our table here. Now, one thing that you won't be able to see is that our y-intercept, our x-intercept, notice when y is 0, x is 8. Okay, so that's actually going to be our x-intercept. So let's go back here and let's graph that. 1, 2, 3, 4, 5, 6, 7, 8. 8, 0, that's 1. So when x is 8, y is 0. We're also going to use the values of 4, negative 1, and 2, negative 2. Okay, so 4, 1, 2, 3, 4, negative 1, and 2, negative 2. And I did actually have one more, so let's go ahead and use that one. We have 1, negative 3 as well. So the more points we get on there, the better we're going to be able to draw our graph. And again, we do not want to cross that asymptote, so therefore I'm going to draw it, and it's going to then all of a sudden just drop down very steeply. Okay? Let's talk about my properties now. Domain. Again, looking from left to right. If I move my pencil across, notice it's not until I get to the asymptote. So my domain starts at 0, and then this graph is going to continue to the right. My range, I look up and down. This is going to continue down to negative infinity, and it's going to keep going up slowly, not as quickly as it goes down, but it's going to keep going up to positive infinity. X-intercept, we talked about that at being at 8. You could also use the 0 function on your calculator to calculate that if you needed. The y-intercept, it does not going to cross that y-axis because I have an asymptote there. So again, there is none for this one. We already talked about the asymptote as x equals 0. All right, word problems. For your word problems, a lot of these are just plugging in. There's really no solving for these. In this case, we're going to approximate the number of students per minute. And again, we are looking for a 500-pound horse. So if W is our weight, we're going to plug in the pounds for weight and then evaluate. So S equals 256.2 minus 47.9 log of 500. And we're going to plug that in exactly how it looks. Okay, so let's go back to the calculator. Go ahead and go back to your home screen. And you're going to put in 256.2 minus, it's going to automatically multiply first for you, so you could put parentheses in if you wanted to, but you don't need to. Log of 500, go ahead and end your parenthesis, and I think I put in 5,000, so let me delete one of those zeros, and end my parenthesis. Hit enter, you get about 126.919. So this is about 126.919. And can you take 0.9 of a stride? Not really, but let's just keep it like that for now. And that's in strides, because we're looking for the number of strides. That's what we're looking for, so we need to label our answer like that. Okay, next one. This is wind speed and distance, the tornado related to the distance the tornado travels. So in this case, we're approximating the wind speed that traveled 150 miles. So which are we going to look for? If we're approximating wind speed, we're looking for S. So we just plug in the value of D, which is the distance that's traveled so far. So 93 log of 150 plus 65. Again, you can plug this in exactly how it looks, 93 log 150. End your parenthesis before you add on the 65. And for that one, you're going to get 267.376, and you're looking for the wind speed, and the wind speed is given to you in miles per hour, so you're going to write this as miles per hour. And the the last word problem. Again, you're looking for find the level of sound, which your level of sound is V. So all of those things go together. That's what you're looking for. So you're just evaluating for the intensity. They give you an intensity of 10 to the negative 5 power. So I'm going to plug that in for I. Now, you could put this in your calculator exactly how it looks, except for it's going to be a lot of keystrokes to put in 10 to the negative 5 over 10 to the negative 16. So it's probably better to use your laws of exponents to simplify that before you put it in. So since you're dividing, same base, you know you can subtract the exponents. So negative 5 minus negative 16 is going to be positive 11. Now you can plug that into your calculator, 10 times the log of 10 to the 11th power, and you were going to get 110 decibels. Okay? And that concludes your review for your quiz on logarithms, which will be on Thursday.